Hi, I'm Adam from Hasura, and today I'm going to walk you through an overview of the Hasura Cloud Console. Here you see the Hasura Cloud Console, you see a number of my different projects. Each project is its own isolated install of Hasura. Now this means that I can have a development environment, a stage environment, I can have a production environment, all managed within one Hasura Cloud Console. What I'm going to do now is I'm going to create a new project, install Hasura as its own separate environment, and we're going to see how we can configure it and then manage Hasura. Clicking here, I'm going to create a new project, and you can see I have the choice between AWS or Google Cloud. I'm going to spin up an environment in AWS, and remembering it's going to be really important to try and spin up that environment as close to where your databases or your users are going to be located. So I'm going to spin up this environment in AWS. Now when that environment has spun up, I can come in here and I can change some of the configuration options for Hasura. So I might come in here and change the name. I'll call this one Hasura Demo Prod. And this will also change the GraphQL endpoint that I have access to. I'm going to also come in here and change the environment that I'm using as well. I'm going to give this one a red color, and I'm going to call this one prod. And what this will do when I log into Hasura is it will give me a visual representation of the environment, just giving me some additional cues to make sure that I'm not changing configuration items where I shouldn't. Now the other thing that I'm going to do here is I'm going to change some of the environment variables. And this allows us, using Hasura Console, to change environment variables that we're actually passing towards Hasura. So Hasura itself doesn't store that information in its metadata, it doesn't store that information in its configuration files. It retrieves it from a secure secrets place. So coming in here, I might want to add a new environment variable that stores perhaps my Postgres connection string. And I'll do that because I don't want to store database credentials in a configuration file. I don't want to actually have to put them in a repo and store them in something like GitHub. I can have Hasura manage all my environment variables for me. So I'll create a new environment variable, and I'll call this one here Postgres connection string, and I'll give this one a value. What that will do is it will store that connection string in a secret stash in a vault, and then when Hasura needs that information, it can pull that in as an environment variable. And I can do this for both any custom string or some of the default environment variables that you can use to manage your Hasura instance. Now we'll talk a little bit around some of these other configuration items here after we log into Hasura and after we configure our API, our instant API. But for now, I think let's dive straight into the console. Now when we log into the Hasura console, the first thing that you'll notice is that there's our environment up at the top. That's what we set it to, a big red flag with the name prod. So that just gives me a visual cue that I shouldn't be changing anything in this environment if I have access to it. You'll also notice that I don't have any queries available in here. So the first thing that I might want to do is connect myself up to a database. And I can do that using the environment variable that I used earlier on. I'm going to create a connection to a Postgres database, and here's my Postgres install here. And I'm going to give it a very simple name like Postgres, and I'm going to use the connection string that we talked about earlier, Postgres connection string. That will go to my secrets vault, it will grab that connection string, and it will make me able to connect to Postgres. So saving that information, you'll notice that Hasura has gone ahead and scanned that database, and it started to understand all of the different data objects, the models, the tables, any views that we've got in there, in order to allow me to track them. And as soon as I track these tables, Hasura will provide them instantly via the API. So let's go ahead and track those tables. Now once we've tracked those tables, Hasura goes one level deeper into the tables, and it understands any relationships between tables. And this effectively allows us to create joins between those tables. For example, we can see here that customers have credit cards associated with them. And they also have plans, and plans are related to devices as well. So we can track all of those relationships very, very easily within Hasura, allowing us to create one schema, one overarching supergraph that pulls in information from multiple different tables using one simple query. So going back to our API, what you'll see now is that where before there were no queries available, we now have access to all of the different data objects from within that Postgres database. So if I want to come in here and start to query for customers, maybe having a look at the first name and last name of all the customers in my database, this is the kind of query I can create. Using the really simple Explorer on the left-hand side, I can build the query graphically, and I can preview it, showing what I'll receive over on the right-hand side. If I want to dive into the SQL that Hasura creates, and it does this automatically and dynamically in real time on every single query, I can click this Analyze button here. And this will show me the SQL that Hasura generates before running it against that database. So there's my SQL query, a very, very simple query. If I now want to create a more complicated query, I can start adding in some additional parameters. For example, I might want to limit this to 5. I might want to order this by customer ID. And I might want to say where the country equals Australia. What this will do again is it will provide all of these different parameters into the GraphQL query. At runtime, it will compile that into native SQL that runs on the database, in this case Postgres, and it will run that query for us, providing us with the results and the answers over on the right-hand side. If we look into the result for that query, if we analyze that query, you'll see that it's very slightly different to the other one. We've now got a where clause in there, we've got an order, and we've got a limit. So any of these different parameters can be used by Hasura to create exactly the kind of query we want against the database that we've chosen. Now this is really simple, right? Because what we've done is we've queried one table, but we might want to start taking advantage of some of those joins that Hasura has created automatically for us. So you'll note here we can now join from our customer table to other tables. For example, I might want to have a look at all of the plans that that customer has as part of their profile. I can come in here to customer plans, and maybe I want to have a look at the cell number, the mobile phone number that that customer has. I might also want to have a look at the start date and the end date of those plans, and then dive into the plan itself to perhaps have a little look at the plan name. And just for completeness, let's also jump through customer plan devices into the device table and have a look at the brand and model of the device that each of those customers has. So effectively what we're doing here is we're looking in our customers table, we're retrieving a little bit of information about the customer, the first name and the last name. We're then joining to our customer plans table to have a look at when the plan started, when the plan ends, have a look at the plan name as well. And then we're also jumping across a couple of tables to our devices table to have a look at the brand and model of the devices that belong to the plans that belong to the customer. Now, in the real world, if we were to create a SQL query like this, we'd probably be spending quite a few minutes understanding exactly the right way to query, remembering the join syntax, all of these kinds of things. Whereas in Hasura, we give it some semantic content. We say we'd like customers, plans, devices, and Hasura will automatically generate the query for us, run it against the database, and provide those results back to us. So here we can see that we've got all of the results as expected. We've got all of the customers, we've got their plans, we've got the devices. We can see here that this person has a Redmi Note 10 Pro, and they've got a cell number 0424651283, start date and end date. And if we analyze that query, we'll be able to see all of the joins that happen against those tables in the database in order to provide us with a really optimized query that runs against that Postgres source to retrieve the results for us. So this allows us to get information from a Postgres data source. We might also want to retrieve some information from a separate database. And Hasura can get any information from any of its supported databases, join all of it together, and return it in one single query. If we head back to our Data tab, what you'll notice is that we can connect up a database of any other different type. And what I might want to do now is I might want to connect up to a Mongo data source. Now, using Mongo, I can connect to database here. And again, all I need to do is give it a name. I'm going to call it support here, and then provide some connection details. Now I can either create connection details using a connection string, or if I want to, I can use environment variables like I did before. Because we used an environment variable before, I'm going to use a connection string now just so we can see that we can use both types, and we'll save that and provide access to the Mongo database. So now my connection details are in, I'll connect up to the database and I'll start to track the tables in Mongo, or rather track the collections that I've got in Mongo. Here's my Mongo data source, and clicking on this data source, you'll notice that all of the collections within that database have been pulled in. I can track that collection in the same way that I've tracked databases or tracked tables within something like Postgres. And I have a couple of different options for how I resolve the data in the data source. I can either paste a sample document in from Mongo, or I can use an existing logical model, and that's a concept that we'll cover in a second, or I can use an inbuilt validation schema that might be on the Mongo data source. Now on my Mongo Atlas data source, I've got a validation schema, so I'll track that collection, and that will automatically create the relationships between what Hasura expects and the data that's in that collection from Mongo. So now coming back to my API tab, if I scroll down here to my user profiles, what you'll notice is that we've got a whole bunch of information that we can pull in directly from Mongo. And I might want to have a look at some of these pieces of nested information, maybe my support related information, and running this again on the left hand side, this query that I've looked at from Mongo retrieves information directly from Mongo Atlas over on the right hand side. If we look at the Analyze tab rather than SQL, what will be created here will be a Mongo aggregation pipeline. So what Hasura is doing in either of these different steps, or indeed with any of its supported databases, is it's going to be converting and compiling from GraphQL over on the left-hand side to database-specific queries over on the right. Now, we've connected to Postgres and we've connected to Mongo, but how can we join the two data sources together? And this is where Hasura becomes really powerful. We can start to connect any database with any other number of different databases. They could be the same database type or different database types. Effectively, what we want to do is create a single interface, a single API, that can connect up to any number of different databases and query them using a single query. So let's now join our Postgres data store with our Mongo data store. And I can do that by creating a relationship between Postgres and Mongo. Now I've got a table in here called member number link. And this table provides me with a mapping between customer IDs over in Postgres and a GUID or a member ID that I know is the Mongo way of relating a user. So I'll build this relationship now. And remember, we can create either automatic relationships or manual relationships. So I can really start to connect anything with anything. Now I'm going to give this one a really simple name like Mongo, and I'm going to go from Postgres here on the left-hand side to my support data source, which is my Mongo data source on the right-hand side. I'm going to look at my source column as my customer GUID, and I'm going to relate that to my member ID. And effectively that will allow me to create a one-to-one relationship between items in Postgres and items in Mongo. Now if I have a one-to-many relationship, as might happen on, for example, our plans or our devices, then rather than creating an object relationship, I'd create an array relationship. And that works between different data sources as well. So creating this relationship, what I can now start to do for the query that we had earlier with our customers and our plans and our devices is augment that with some support information from Mongo. I'll pop open my history tab to find the query that I had earlier. There's my query. And I'll now scroll down and find the customer member number links, join. I'll find the Mongo join, and I'll start to add information from Mongo. Perhaps that support history that we talked about, the status, and the issue. So what we've got now is we've got all of this information here coming from Postgres, and then we're also joining with information here from Mongo. Running that query, what Hasura is doing is finding the most efficient way to talk to multiple different data sources, trying to find how we can query those data sources in as few queries as possible. And now the data that we receive back shows information from Postgres. There's our customers, our plans, our devices, and hey, we've now got some support history coming in as well. So on the front end, we're asking for one query in either GraphQL or REST, And on the back end, on the Hasura end, we're doing the hard work to retrieve that information before providing it back to the front end. So we don't need to create multiple endpoints, we don't need to create multiple APIs, we don't need to create multiple integrations between Hasura and backend data sources. We just create one integration with Hasura, and Hasura does all of the hard work to connect up to different data sources for us. And remembering, any single one of these queries can also be configured to use REST as well. So any query that I design here using my interface in GraphQL, I can simply click this REST button and this will convert this GraphQL query to a REST endpoint for us. There's my GraphQL query, and I can create an endpoint in here that does exactly the same query, talks to Postgres, talks to Mongo. I'm able to use parameters, I'm able to use path parameters or query parameters to alter some of the calls going to the backend, effectively giving me exactly the same functionality in both GraphQL or in REST. So far we've talked about queries or reads with Hasura, but also Hasura supports any kind of write operation as well. Taking a look in here, we can change this query to a mutation, and then if we add this mutation, you'll see that all of the different operators have been provided automatically to us. Again, we'll need to configure some permissions, and we'll talk about how to create permissions in a second, but all of these are available should we have those permissions available to us. We can insert plans, we can update plans, and we can delete plans. The final component here is something called subscriptions, and a subscription is basically a real-time query. It's one of my favorite items within Hasura. And to create a subscription, what I'm going to do is I'm going to connect us to a new database and show how subscriptions create a real-time connection between the database and Hasura itself. So coming into data, what we'll be able to do is connect up a new database. And I've got a new Postgres database with an environment variable that I'm going to use for this demonstration. Now the environment variable here is subscriptions.db. And what we can now do is we can see that our subscriptions database has been pulled in just in the same way that our other databases have. You can see I've got two different tables here. I've got a calls database, a calls table, and a text table. And if I track those tables, I'll now be able to instantly query them via the API. But I'm going to do it using a subscription this time, in effect creating a real-time connection between Hasura and my backend data source. So coming back to my API tab, I'm going to create a subscription against data in my texts table. Looking at my text table here, I might want to retrieve the message type, the text ID, and perhaps the timestamp. And I'm going to order this by text ID descending. So let's come in here and I might throw a limit on that as well, and I'll run that subscription. And what you'll see is that when this subscription runs, it doesn't actually run as a single query. It maintains a connection to the database. If we look over on the right-hand side, what we'll notice is that the query is changing, or the results from that query are changing as new items enter that database. So if you've got a database and you'd like access to real-time data, if you want access to the front end or to the experience layer of real-time data, then all of this will be pulled in from Hasura to the front end as soon as those items hit the data source. And in the same way that we might want to act on information as it goes into Hasura or into the database, we can also create an event. And an event allows us to act on any item as it runs into the database. So creating an event here, I might want to act anytime a new text enters that database. I'll come into subscriptions, I'll add to our public schema and our texts table. And what I can do is I can select insert as an operation to act on. Call this one insert text. I can then fire off an event to an external webhook as soon as any text enters the database. So whether I'm creating a subscription which gives me access to that information in real time, or if I'm acting on that data as soon as it enters the database, Hasura provides me with both different options to create a more real-time mechanism of interacting with data. To import an OpenAPI spec document, we take our document from either a third-party source or one that we've created ourselves, and we paste it into this window. And What this will do is it will provide us access to track all of the different REST endpoints that are defined in that document. So you can see here I've got a REST API and it's going to provide me with access to retrieve users. Now this works across all CRUD methods, whether we're getting information, posting information, patching information, all of that kind of thing. By creating this, it will be the same as tracking a table in a database. And you can see over here that we've tracked that information and we now have access to retrieve users from that third-party REST API. Now coming back to our API tab, if we were to scroll down to the REST endpoint that we've just connected to, get REST API users, and select a couple of the different parameters here, maybe the email and the roles, what Hasura will do is it will connect to that REST API, it will retrieve the information, and it will provide it back to whatever is calling Hasura in the first place. And we can do this with REST APIs like you've seen here, or with a GraphQL API. So let's go and do that with a GraphQL API. Just in the same way that we've connected to a database or a REST API, I'm now going to connect to a GraphQL API. So I'll call this one external GraphQL, and I'll give it a GraphQL URL. So that's a URL that I've got access to and I can retrieve information from. What I'm now going to do is I'm now going to make sure I forward all of my headers to make sure that anything I'm sending through to Hasura, I'm also sending back to that GraphQL API, and that can be useful for things like permissions, and we'll cover permissions shortly. By adding that remote schema here, I now have access to retrieving the information from that external GraphQL endpoint. What you'll notice now is that since we've added that GraphQL URL, we now have access to all of the different operations that GraphQL API provides us. So we've got some query operations here, we've got some mutation operations, and also some subscription operations. If we go to our API, we'll now see all of those reflected within this interface. So you'll notice we've now got access to an AI search. So I can come in here and I can say, hey, my phone is wet. And I might retrieve a title and a body for content that I return back from that API. You'll notice that this is Hasura connecting to another GraphQL endpoint and retrieving some information back to do with what happens if my phone gets wet. Now we've looked at creating integrations with databases, REST APIs, and GraphQL APIs. I think the key thing now is to understand how we can put some permissions on top of all of those different APIs, making sure that only users with the right level of permissions retrieve the data that we want them to have access to. And this is where Hasura's granular role-based access control and attribute-based access control permission system comes into play. I can look into my database here, and I might want to have a look at my customers database and restrict access only to people who have access to that customer database. For example, the customers themselves. In this tab here, this permissions tab, I can create any number of new roles, and I might call this one customer. With the customer role defined, I can now define all of the different permissions that are involved in that table, from inserts to selects, updates, and deletes. And these will reflect immediately back to the GraphQL endpoint or the REST endpoint that Hasura generates, only providing access to users based on the permissions that they've got. So I can say here that Hasura provides access to customers to select their own data, and I can be really granular around what kind of data I want that user to return back. I might, for example, say that, hey, only customers who map their token value of their customer ID to the customer ID column in the database can retrieve those results. So if I'm passing a customer ID of number 7, for example, it will only retrieve results where my customer ID maps to that. I can also control the columns that get returned as well, so I might want to only see the first name, the last name, the phone number, and the email address of that user. And in doing so, I can show rows and columns that are related to that user, and only rows and columns related to that user. So let's now come back to our API. Let's now add in a couple of those keys, and these could be derived from a header value, from a token value, or from some kind of session variable, and see how we retrieve data for that user. Now I've added in two additional session variables here. I've added in a role, which maps to the role that we defined in our permissions, and I've added in a user ID, and that maps to the permissions item that we just defined. I've already pre-filled these with customer and the number 7, and you'll notice that the available queries have reduced to only the one that we defined within our permissions. You can also see that only the fields that I've defined have been made available here. So this means that if I'm customer number 7 coming in, I can only query for customers, and I can only query for these columns. If I run that query, what you'll notice is that I only get information back for one user. And so we can create really granular methods of connecting our customers, our end users, with the data in the database. If we look at the query that Hasura creates, you'll notice that we've added in a where clause. And this where clause here is exactly what defines the permissions. We push those permissions down to the database, and we use the data structures and the data models in the database to govern the permissions that are retrieved back and the data that's retrieved back for us. So far, we've managed everything within the Hasura console interface here. But what I might want to do is I might want to extract the metadata, extract the configuration from this running environment, store it in a version control system, something like Git, and then push that up to one of my other Hasura installs. So what I can do is I can open up my terminal, and I can use the Hasura CLI tool to download that metadata, download that configuration information, set it into some kind of version control system, and then either push it up manually or integrate with Hasura's deployment system to push it to another instance of Hasura on Hasura Cloud. Now the easiest way to retrieve that metadata is to use the Hasura init command. Passing both the admin secret and the endpoint from my Hasura interface, from my Hasura console page, I'm able to create a directory that allows me to pull metadata into it. Once I have this metadata on my local device, I'm then able to very, very easily push that up to either a version control system or to another Hasura interface through which to mirror the configuration. As you can see here, I'm exporting the metadata directly from that cloud-hosted, Hasura install. And now that I've got it, I can start to go back to my Hasura interface. And now that I've got it, I can start to integrate with things like Git to deploy on any kind of change. Using Git deployment here, what we can see if I sign in with something like GitHub is I'll be able to link up to the repository, and anytime that repository changes, that metadata gets pushed immediately from Git into Hasura, effecting changes. Now the final thing to talk through is Hasura's inbuilt monitoring capabilities. We can either push to an OpenTelemetry endpoint and send logs, metrics, and traces to something that you manage, perhaps something like Jaeger or Prometheus, all moving into some kind of Grafana dashboard. But we also provide inbuilt monitoring on Hasura Cloud itself. And this will give you an overview of things like the request rate, the error rate, and the average execution time for all of the queries, mutations, and subscriptions that you have access to. You'll also notice that we have a health tracker down here that looks at all of the databases and ensures that those databases are healthy. For example, our Postgres database here, our Postgres database here, and our support database here, all looking pretty healthy to us. Diving into this in a little bit more detail, we can start looking at things like errors, looking through the error log, looking at things like usage to determine which of our API endpoints is being used more than others, and then having a look at all of the operations that have run against the database. So all of this providing us with really good control and visibility over what's happening with our Hasura Cloud instance. Hope this has all been very helpful to you. More than happy to dive into any of these different items in a little bit more detail. Otherwise, looking forward to chatting soon. Cheers, bye.